I'm Tim Ventura, and we're joined today by Peter Garretson, an independent strategy consultant focusing on space and defense. Peter's accomplishments include a 33-year career with the Department of Defense and service in a number of prestigious roles, such as the Chief of Future Technology for USAF Strategic Planning in the Pentagon, the Director of the Space Horizons Task Force, and the Division Chief of Irregular Strategy, Plans, and Policy, and as the Strategic Policy Advisor to the Chief of Staff of the Air Force. Peter has also served as an assistant professor of comparative military studies at the USAF Air Command and Staff College, as a member of the National Space Society Board of Directors, and in his current role as senior fellow in defense studies at the American Foreign Policy Council. Peter's also the author of Scramble for the Skies, the great power competition to control the resources of outer space. And he joins us today for an impromptu discussion of near and far future space technologies. So Peter, welcome. Let me start by thanking you, sir, for your many years of service. And I want to start out big with this one. I want to start with Space Marines with jetpacks, okay? Ithacus was a study back in 1966. You told me about this one, inspired by General Wallace Greene, who proposed a rapid strike battalion of 1,200 rocket commandos deployed by an intercontinental rocket so that the need for overseas bases could be reduced. So I wanted to get what your thoughts are on this one. And could this thing have even worked?
Well, there's so many reactions. On the one hand, the kid in me that grew up, reading popular science and popular mechanics is like, wow, that is just super cool. What could be more interesting than that? I think that they probably were looking at the physics to see. I doubt that it would have been cost conscious. On the other hand, our overseas bases are quite expensive to maintain too. It is interesting to think about how ambitious the thinking was at that time. I mean, this was the time of Sea Dragon. This was also, we were thinking about putting up just massive stuff into space. This was sort of contemporary with Project Orion, and the strategic orbital base, which was being thought about at that time. This was really a period of exceptionally advanced thinking. Not only did you have the strategic orbital base in SAC that was connected to the Orion nuclear pulse detonation engine that DARPA was pioneering, but you had plans for a manned orbiting laboratory, much more advanced than most people are familiar. Most people are familiar with like something, small, based on like Gemini hardware or something. But in point of fact, they had actually wanted at one point to put up a full squadron that would be constantly refueled and replenished by like 72 annual reusable spaceflight in that period. This was Dinosaur was one of the things on the table then. And it's a good question, like, why did all this never happen? Why did it collapse? There are various reasons. I'm not sure because exactly why Ithacus didn't go further. Many of these others were in competition. There was a manned vision of space that was in competition with an unmanned satellite vision and unmanned ICBM vision that sort of moved faster. And so, rather than having a, Dinosaur, we got the ICBM. Rather than having manned orbiting laboratory, we got NRO satellites. And we certainly could have had NERVA and Project Orion, but when we signed the limited test ban treaty, even though it was legal under the treaty to continue, I guess the administration just thought it was too provocative. So there was a plethora of really exciting thinking that sort of terminated as manned roles moved to NASA, and as the NRO saw success with unmanned spy satellites.
Yeah, it's interesting. I mean, when you think about it, you think back to, I guess, 1966, right? So the people, I mean, these were World War II veterans, and so there was a lot of that post World War II in the military at that time. You also had a lot of that 1950s, 60s Cold War push, right? It was, be creative, think big, we need to defeat the Soviet Empire. So there were a lot of those. But then I guess the other part of it is the people who would have been in the military, the strategists of that time, they grew up reading Buck Rogers and Flash Gordon, right? So for them, this kind of could have been, I'm sure that they had that childhood dream vision too. They're like, we could make this real with the technology that we have today. So
Yeah, and the idea, would sort of go to sleep for quite a few decades before it would reemerge.
yeah. Well, let me, before we move on, let me run you through. I want to share screen real quick. I actually found, you sent me a couple of these photos. So this one is, I think this is probably the best known. Now I could put links to some of this stuff in the notes, but there we have it. Space Marines with jetpacks. And we've got like an old rocket, and you can see actually there's a Marine with a jetpack in the air, So that's a pretty amazing vision back for that era. And then let me see, I'll go to the next one. Again, this is one of the ones that you sent me. Now, this, if I remember right, this is the Rhombus rocket, right?
Tim, I am not so clear as to where Rhombus and Ithacus Junior, sort of start and end. But there are a series of these, that are all sort of in a family. There appears to have been at least one really forward-thinking industrial designer that was thinking this through. And there was, like, I think one version that was sort of in the 200 to 300 troops, and then there was the full 1,200 troop version, and just quite something when you think about the scale and size. That's something that would be carrying that many people suborbitally would be carrying.
Yeah, it's amazing. Well, and Pete, again, I want to thank you so much for joining me to walk the audience through this, because your background and your expertise, you're one of the few people who knows this history. These ideas. Most people, this is almost like forgotten history. So this is, again, you sent this one to me. This was in an article on it. What I thought was interesting about this is um, that does not look like the kind of launch platform that wants to be on top of a carrier. I'm thinking, is that going to tip the ship over? I mean, probably not, but I don't know. That doesn't look like it wants to be there.
Again, it's just on a scale of ambition, that is only now sort of reemerging, with SpaceX and Blue Origin. I mean, of course, Blue Origin intends to land on a fairly substantial ship, and this, and there are sea launch platforms, of course, today. Nothing on this scale. Here, you're seeing something that is literally like a nuclear aircraft carrier sized. But here at least you've got your cooling water right there, right? I mean, it's a little easier to source that. But you can imagine that, why might you want something like this? Well, the geometry of your suborbital to put it where you want to have exactly the response time that you want. I mean, it's a flexibility of thinking that I think actually does some level of credit to the folks.
Yeah. These are big ideas. Let me put the article up here too, and this is the one that you sent me by Steve Weintz, and it was literally entitled "Space Marines with Jetpacks." And Cold War rocket ship Ithacus would have hauled a battalion of jet troops anywhere in an hour. So that's on Medium, for anybody who wants to kind of do more research. But let me stop sharing there for a moment. Again, this is just fun stuff to cover. So thank you so much for joining me to kind of go through this. Now, there's a modern version of this. So this was the small unit space transport and insertion, or SUSTAIN. And this is a concept that was proposed in 2002 by the US Air Force and the Marine Corps. So they resurrected this idea. They want to deploy Marines via spaceflight to any location on Earth, except no jetpacks this time, right?
Yeah, I don't remember any jetpacks in it, but I was involved in Sustain. It came out of a Marine general officer had basically, stated he had, a urgent requirement to be able to rapidly deploy anywhere. And keep in mind that this would have been circa 2000 and somewhere between, my memory gets hazy now, but this would have had to have been between sort of 2004 and 2012 when this started. So this is sort of long before, we had the rise of commercial space. So, certainly Bezos and Musk would have started their companies, but there would have been no headlines, about them. And so, the Marine general had sort of passed this to his requirements guys. There was a very creative guy named Franz Gale who was there, and another of my compatriots who had been at DARPA, Paul Danfus, who was also involved with the NSSO solar power satellite study. He was involved in it. It involved a great back and forth between DARPA and Air Force Research Lab. And what distinguishes this from later efforts, of course, was that the assumption here was really that the government would have to create something brand new and novel that had not existed. And so there was a desire to create a roadmap. I'm not sure that the roadmap was ever, publicly released for Sustain, but it represented some creativity. And I remember sort of one of the last two slides of General Pete Warden's briefing at the Pentagon when I had him out as a major, talking about this as a sort of a creative idea that that was sort of being pushed outside the traditional space community, which it was. But Sustain was part of a community that sort of kept alive the post DCX flame. So in the 80s, there had been this program at the Strategic Defense Initiative Office of what people might be familiar with as Star Wars, of trying to stop nuclear missiles from flying through space. And one of the reasons why they, of course, were pursuing it was the ability to sort of cheaply get into space and rapidly. And that was the first vertical takeoff and landing reusable vehicle. It was a hopper. It never went all the way to space. And, Congress loved it. People loved it. The videos, there are some amazing videos of that. Well, though, some of the folks involved in that form a continuity. So Jess Sponable, that was, he was on that program, and then he was on sort of a DARPA Air Force related project called Hot Eagle to think about how you might be able to use reusability to go, rapidly places. And so that sort of got tied in with the Marines' desire to explore whether or not that could be used for Sustain. And of course, Sustain, you can hear small unit. So, they weren't thinking about battalion size. They were looking at, putting a small, team of Marines anywhere very, very rapidly to be able to cope with a crisis. And of course, at that time, there really weren't platforms that could even get you there or get you there with very much. And some of that has changed since. We now have platforms that likely have the lift to get you there. A remaining problem is, how do you get back out? And if you're in an austere location, and then how big would you want it to be? Usually you're going to have significant problems with its survivability, because we build aerospace vehicles to be exceptionally light. You're now, flying into a place where you've got to worry about, small arms fire. But one of the things that made this interesting and attractive as a concept was that there were several things that made it interesting in particular to the Marines. So one of the things that made it interesting was, of course, the rapid response time. That, unlike having to fly for 30 some hours in an airplane, plus stops and multiple air refuelings to get someplace, and have to deal with overflight permissions, you could essentially get anywhere in under an hour. And even if you assume that it's going to take forever to, get the permissions, you still, once the permissions are there, it's an hour to wherever you go. And the other one I sort of alluded to is that unlike in air and in land, you wouldn't have to worry about overflight permissions. So, you only have to worry about the, well, obviously you have to worry about flying through your own airspace, which is actually not minor. But, once you are coming down, as long as you're not trespassing, as long as you're sort of coming straight down, if it's a friendly country where you've got permissions, you just need their permissions. If it's an unfriendly country, you're essentially invading, so you're not going to be asking for them for permissions. But, in space, you are allowed freedom of transit above 100. Well, it's not exactly defined, but, you're allowed freedom of transit in space, which many of us sort of assume is about 100 kilometers. So, this would essentially obviate a lot of permissions that that add time to your ability to respond, that add complexity and reduce your operational security. So, certainly the idea of like, wow, wouldn't it just be awesome if I could, put a bunch of folks down, and more recently, not even people, what if you could just put a bunch of, UAVs down, or, some other type of unmanned system, remains attractive, at least as a vision. It still seems like, landing a rocket in an unprepared area is going to be a challenge.
Yeah, yeah. Well, actually, let me do a screen share really quick here, and I have a couple more. I was organizing these just a second ago. So this, you sent me this. This is the small unit space transport
Oh
and
yeah,
insertion
Bob
stuff.
Lancaster is on there too, who was also one of the visionaries.
Yeah, yeah. So I'll put a link up in the notes to this, and this was the actual report. And then I wanted,
That's not the report. That is just a presentation. The actual roadmap and report is many, many pages of full text.
okay. It does look like a pretty good outline of what's in it, though. Yeah, I see what you're saying. This is, yeah, kind of a PowerPoint type thing. So then I want to show this is the Delta Clipper DCX-A. I'm not going to do the whole thing, but this was the DCX that you were talking about. So you were saying that this thing is a hopper, right? It doesn't go all the way to orbit. It just goes up and lands. I remember reading about this in Popular Science in the 80s. Didn't they had issues with the takeoff and landing though, didn't they?
One of the retractable legs failed on one of the landings, and it was unfortunately never rebuilt. But it did some pretty astounding control maneuvers, especially for its day. That we really haven't seen until the tests of Starship fairly recently.
Mm. Yeah. Well, so that's the Delta Clipper. And then this next one, we haven't talked about this, but I'll put this up before we touch on it. And I want to come back to this with you like next week, hopefully. This is the Fast Space report. This is again another giant idea, but I think it's more practical, and it has a different kind of appeal, right? It's the economics of leveraging low-cost space access and bringing that into the DoD, in a way that saves money and enables fast transport. So let me stop the share on that. But that's the Fast Space report. Now, is there a way to touch on that really quick? One of the ideas that came out of that was, again, Fast Space had this concept for rocket cargo, which sounds kind of like Ithacus, but this idea was to leverage cost factors, I guess, kind of projects like Starship for point-to-point travel, right?
So, all this has some wonderful continuity. So, you remember I mentioned Just Spawnable. So, Just Spawnable had been back at Air Force Research Lab, and there had been, an interest in re-examining the possibility of reusables. And so it had sort of started off, or I would say that Air University had started thinking about a concept that they titled Air Guardian. And initially it was called Air Guardian, went through a few different names. And it was initially imagining this idea of this much faster way of getting around the world, again, using reusable technology. And part of it was, like, well, how could we more rapidly respond to, something like Benghazi, where the embassy had been under assault, and, you really would have needed something very, very timely. And so there had been some war games. There was one particular guy, Gabe Arrington, that was a big proponent of this. This eventually, because of my history in Sustain, I was brought into it. It grabbed the attention of the Air University commander, General Steve Quast, who had been a fighter pilot and appreciated the possibilities of speed, and had done his thesis on space power doctrine, and so was inherently friendly to space and looking to do big transformational concepts. So, we had sort of started, thinking about, what is the, potential military utility of, reusable space access. And then all that was happening at the same time that commercial space was starting to think about, sort of two ideas. One idea was what we now call mega constellations or very large LEO. There really weren't any at the time. Planet, I think, probably was the largest, but there was no Starlink at the time. And these companies had shown an interest in being able to land rockets. And so what sort of happened with the Fast Space Report, which was truly a fascinating moment in history, and one that is in many ways ought to be considered sort of a founding document of the Space Force, although it doesn't really mention the Space Force at all. I'll explain how it's connected. So we now have these billionaires involved in launch vehicles. And so the idea was like, let's think about what would be the implications for national security, and could we encourage this? So Air University had an extremely different way of going about this than the rest of there was no Space Force at the time, than the Air Force had. So the Air Force typically had defined requirements for what it thought it needed, and then it would have a dialogue with industry about the extent to which they could fulfill their requirements. And our tactic of our team, we had quite an impressive team that grew over time with names like Bill Brunner and Charles Miller and Tommy Schilling and Joel Sercel, Coyote Smith, myself. I know I'm forgetting others that were quite important. And so our team, Yogi Levitt, for instance, we got a chance to visit these cutting edge new space companies when very few people had a confidence in them. And we asked them what their visions were, where they wanted to go, what they thought the future was going to be like, and trying to put together what that would mean for space. And that was the same time that I was running the Space Horizons Research Task Force, which was sort of an internal space think tank on the future of space, trying to think through how space power might be different in an age of asteroid mining, which we had begun to talk about that time. And so in the course of this, it became clear to us that the ability to harness reusable spacecraft carried with it enormous potential in terms of lowering the cost to space over time. And by the way, in the report, there are a couple of really nice graphics that show a virtuous cycle and an industrial learning curve of how you could get the cost of space access down. And then that would enable just a scale of activity in low Earth orbit for command and control and communications that we'd never seen before, which has borne out. And so there were a few things that this report, I think, was absolutely prescient about. So the first thing was that reusability was coming and was worth our investment. The second was that the United States should adopt, a COTS-like, which is a milestone-based public-private partnership where the true prize is a government contract, and then that there would be very large LEO constellations, which Starlink, has happened, and that we should be experimenting, with these systems for their military utility, including for suborbital point-to-point and delivery, which ultimately resulted in two related but separate programs, one of which is Rocket Cargo, and the other is the Transcom effort to look at an en route logistics system for Rocket Cargo.
Well, and Pete, on that note, let me stop you for just a second. I want to share the screen again, and I'll put the Rocket Cargo video up. If I can find, there we go. Okay, so I'm going to play this for everybody, and they can see this is the AFRL video. And again, thank you for sending me this link. So this is, I guess, their visualization of how Rocket Cargo would work. This is an ongoing effort, right? This is something they're currently working on.
That is my understanding, that Rocket Cargo remains actually fairly well supported. Now, it's important to talk about, what Rocket Cargo is and isn't. So Rocket Cargo is not the Air Force building this rocket. It is, exploring in a cooperative, agreement how you would do things like you see here. Like, how might we load, military things? How would you put the interface on rockets that others are, in fact, already building? And then how might you explore the ConOps with them to just sort of better understand things? So, it basically relies on the ability of the private sector to sort of bring, the rockets themselves. But we'll see where it goes, because it seems to have decent support from more than one potentially interested command, both Air Force and combatant command. So,
well, now the cost for this, and you corrected me on this, because one of the things that I thought was this will be incredibly expensive, even with the cost reductions. But you'd said that the cost could actually be less than shipping things on a contemporary cargo plane, right?
So, I mean, all this depends on, a lot of different assumptions. But if you look at, for instance, what SpaceX is trying to do with Starship to Earth, which is another, great video, and you look at sort of the cost per hour of military aircraft that it takes to move through the world, depending on the fully burdened cost of that, including potentially air refueling, if you're going halfway around the world, it might be, there are some scenarios in which it could be cost competitive, and there are others where it's not cost competitive, but it is still attractive because, like, let's say that it ends up being 10 times the cost for the payload, right? there are things that are of such importance that it would be well worth paying, a tenfold increase in price over what it would take for air. And I'll give you an example. Like, let's say that you have, well, let's go to something that, perhaps the a listener might be familiar with. So imagine that you had an airplane, like maybe in Gulf War, it might have been, the stealth aircraft. And let's say that, you had to ground the fleet because some part, was bad and you needed to replace, all the parts in, 10 or 15 aircraft. And they're tiny. Like, let's say that they're just this big. Well, if your entire, offensive operation has to wait, on this one part, for the whole thing to be, executable, you might be willing to spend an enormous amount of money, not to, lose a larger effort or lose an advantage. And so, there are certainly, and like I used to fly the C-5 Galaxy, and I can remember, we would have legs where that giant airplane was empty except for literally a box this big, because it was what was called a MICAP, or mission capable piece of hardware, that was absolutely, had to get someplace astoundingly fast for some national purpose, and we were the only airplane that could get it there fast enough. But like I said, it depends on if you're flying, if you're going someplace close and not halfway around the world, probably doesn't look so good. But if you're trying to do it at the extreme reach, then it may be a different story.
Yeah, yeah. Well, so it sounds like the takeaway from all of this is that, when we visualize rockets, I think, and I know I'm definitely one of these people. When I think of rockets, I'm thinking about going into space and then going to the moon. But you don't have to. You can go into space and come back to Earth, or in the case of the DCX, you don't even have to go into space. You just come back to Earth, go up in the air. So, it's kind of a different way to approach rocketry, I guess. And I
The
know that.
payload is much larger if you're just going suborbitally. And there are multiple different ways with a two-stage vehicle. You can do, sort of a, you know, two boost back, one boost back, once around. It's quite complex in terms of what it is. But the key thing is, if you're fully reusable and you're able to recover the vehicle, which, some of these scenarios, of like blasting into the middle of nowhere, you wouldn't. But others, like say, you had to get something from, DC to Hawaii, or DC to Okinawa, or Hawaii to Okinawa, for instance, those, you know, that's now an en route system. And so I think that's some of the things that are being explored is how could you use this for timely, cargo delivery, in some sort of an en route port system.
Yeah, absolutely. Well, Pete, let me thank you for your time today, sir. And again, thank you for your many years of service. And I hope to have you back in the near future and we can talk more about fast space as well.
Absolutely. Thanks, Tim.